Now we're going to talk about density altitude from pressure altitude and true altitude conversions. One thing I hadn't mentioned that I thought was just kind of cool, gee whiz information, is that when you zero out the E6B, meaning you place the 10 on the 10 and the 60 on the 60, you get standard atmospheres. So like your standard atmosphere is going to be plus 15 degrees Celsius at sea level, and that's located on both of these pressure altitude windows. And also at that sea level, you'll have a density altitude of 0. And so this is the standardization, the making sure that your whiz wheel is calibrated is a quick, easy check. So let's just jump right in. The first problem, we want to get density altitude from pressure altitude. So here's the problem. You're flying at a pressure altitude of 12,000 feet with an outside air temperature of 0 degrees Celsius. What is your density altitude? So for these calculations, we're going to be focusing on basically these two windows. So I'll zoom in a little bit. So pressure altitude in thousands of feet. Before we get started, set pressure altitude opposite the temperature or outside air temperature in the window, and then opposite calibrated airspeed on inner scale, read the true airspeed on the outer scale, or read density altitude at the center mark there. So that's just, there are directions on the E6B if you forget this. So 12,000 feet and 0 degrees Celsius. So 0 degrees Celsius is plus 50 to the left, minus 50 to the right, so 0 degrees there. And we want to find this 12,000 feet. So there's 5,000, there's 10,000, 11, and 12,000 feet. So 10, 11, 12. So 0 degrees Celsius at 12,000 feet, pressure altitude. And then simply, we just go up to read the density altitude. So in this case, it looks like 10,000, 15,000. So 10, 11, 12, 13. So 13,000 feet is our density altitude. That it is the altitude corrected for non-standard temperatures. Okay. Let's do another one. 4,000 feet pressure altitude and 15 degrees Celsius. So what I like to do is find the plus 15 degrees first, and then I'll put my pointer on that. That's the size of a bowling ball, and then drag that to where I want it. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so 5, 10, and we want 15. So it's this line here. Now that 15 line, we need to set that on 4,000 feet density pressure altitude. Forgive me. So there's the 5, 4, 3, 2, 1, 0. So I always like to make sure that the hash marks line up and then double check your work, especially during the written test. Okay, so we have 0, we have 5, 10, and 15. And we're lined up there at 4,000 feet pressure altitude. We come across here and we look at the density altitude is just below the 5. So what do they say? Here we go, 4950. That seems about right. I'd believe that because that's 5,000 feet density altitude. That's 4,000. So 4950 is just below. You could even call that 4,900 if you wanted to. Okay, one last one just to kind of get everything solidified here. 15,000 feet and minus 5 degrees Celsius. So let's find that minus 5. So there's the plus 50, minus 50. So it's going to be on this 5. So these go by 5. So there is the minus 5 line at the tip of my pointer. And we need to go up to 15,000 feet. So 5, 10, and there is 15,000. And now we're going to go over to density altitude. So it looks like it's just a straight up 16,000 feet, which looks like it works out with our answers. Okay, now let's talk about the true altitude portion. Now I'm just going to standardize this real quick. And in the true altitude window over on this side, we're going to be working here with the pressure altitude and the temperature. And then we're going to be reading the inner scale and the outer scale. Okay, so the first one, so right now, all we're going to be worried about is the pressure altitude and the outside air temperature. So 12,000 feet and minus 10 degrees Celsius. Okay, so on this one, because this rotates, I'm going to find the 12,000 foot first. So there's 10, there's 20. So 2, 4, 6, 8, 10. So that's all right. So now here's the 12,000 foot line. And then let's take this and line it up with minus 10. So we have plus 10 over here and we have minus 10 over here. So you can see 0, 5, 10, 15, and minus 20. So, whoops, 12,000 feet. So there's minus 10 degrees Celsius. And that looks pretty good. Now, the next thing we're going to do is look at the indicated altitude on the inner scale here. And we're going to go over here to the 14,000 foot indicated altitude. And then slide across and let's figure out what our true altitude is. So that's 13,000, that's 14,000. So 13, 5, 6, 7, 8, 9. So 13,900 feet. And there it is. All right. Now let's go down to the true altitude problem number 2. We can set it back to 10 and 10 and 0 and 0. All right, so we have a pressure altitude and the outside air temperature minus 15 degrees. So 16,000 feet pressure altitude and minus 15 degrees Celsius. So we come over here, and I like to find the pressure altitude first, so 16,000. So 10, 12, 14, 16,000 feet pressure altitude, and we're going to find minus 15. Dang, it's really close. So 0, minus 5, minus 10, minus 15. And then let's see, 10, 12, 14, 16. All right, so verified it again. So that is lined up. Now we need to find our indicated altitude of 18,000 feet. So I'm going to zoom out over here, and we're going to go over to 18,000 feet. And we have just passed the 18,000 foot mark. And so that's 18,100. No, actually, that's 200. 18,200, 400, 600, 800, 19,000. Okay, so these are 200 hash marks. So we're about halfway in between. What does it say? Oh, okay. Well, there you go. 18,100 feet. I'm not going to split hairs there. Whoops. That's there. There's the answer. Find the 18,000 on the middle scale and then read the outer scale here. So 18,100, we'll call it halfway in between there. Okay. All right. The last one is going to be a pressure altitude of 6,000 and outside air temperature of 5 degrees Celsius. So let's go find the pressure altitude of 6,000. So there's 10. Let's see, 0, 2, 4, 6, 8, 10. So there's the 6 mark. And then plus 5 degrees Celsius. Gosh, it's already there. All right, well, that lined up. So 0, 5, 10, 15, 20. That makes sense, and that's on the positive side. I can't tell you the number of times I've actually screwed that up. All right, so that looks good. Now I'm going to zoom that out a little bit. And now we need to say indicated altitude of 7,000 feet. So we're going to go over here to 7,000. And let's figure out. So 7,000, 8,000, so 7,500, 7,100. So half of 100, let's call it 7,050. We'll call that. Oh, look at that. So there you go. You have density altitude conversions for non-standard temperature, and then you have the true altitude conversions for your pressure altitude and the air temperature or outside air temperature. Hey, if you've enjoyed this video and you want to learn more about helicopters, I got a free course to get you started with helicopters. There is a link down below in the description. Love to help you out.